Cannizzaro reaction. Cannizzaro reaction. What is the definition? Aldehydes without alpha hydrogen undergo disproportionation. In the presence of concentrated base NaOH, within the bracket 50% NaOH also considered as a concentrated base according to last year exam paper. Okay, previous year papers. Don't consider 50% as a dilute, consider 50% as a concentrated. In the presence of NaOH to give carboxylic acid in the form of salt and alcohol. So alcohol and carboxylic acids are the final products of Cannizzaro reaction. Let us see one example. Once look at this. Aldehydes without alpha hydrogen. Formaldehyde will undergo Cannizzaro reaction. Why? Because it is not having alpha hydrogen. Benzaldehyde C6H5CHO undergo Cannizzaro reaction. I have given some other examples also. What are that examples? What is its name? Give IUPAC's name. 1, 2, 3. 2,2 dimethyl propanol also undergo Cannizzaro reaction because alpha hydrogen is not present. And one exceptional cases. Exceptional I given. What is that exceptional? No. Even though it is having alpha hydrogen, it undergo Cannizzaro. Generally, aldehydes without alpha only undergo Cannizzaro reaction. But this is having alpha hydrogen. Yesterday I given, right? It undergo Cannizzaro reaction. Cannizzaro because these are not having alpha hydrogens. But even though having alpha hydrogen, it undergoes Cannizzaro reaction. Clear? I'm taking formaldehyde, HCHO. 2 moles of formaldehyde. Formaldehyde also called as methanol. Concentrated sodium hydroxide. One molecule converted to acid, another molecule converted to alcohol. Disproportionation. One molecule undergo oxidation, another molecule undergo reduction. Disproportionation reaction. Okay. Take benzaldehyde. Same 2 molecules of benzaldehyde. Sodium benzoate and benzyl alcohol. Sodium benzoate and benzyl alcohol. Okay. Write the mechanism part. Yesterday we completed up to this. Right. See the mechanism for formaldehyde case. Mechanism for first. Concentrated base, sodium hydroxide, HCOONA and CH3OH. Have you given mechanism yesterday? Mechanism also over. With mechanism. 2 steps, right? Okay, then. Mechanism also finished, no? Okay. Now let us take different. What is step 1 in the mechanism? Tell me. Attack of nucleophile on the carbonyl carbon. What is rate determining step? Step 2. Hydride ion transfer of hydride ion. Right. Okay. Yeah, we stopped at 2 different cases, right? One formaldehyde, one benzaldehyde we took, right? Okay. Right. See, one note I given, important note. Look at this. The aldehyde which is attacked by nucleophile will convert it to acid. Based on this, we can expect one question. So normal reaction, simple reaction is easy only. Everyone can identify the reaction. Okay. But when we take different aldehydes without alpha hydrogen, which will convert it to acid, which will convert it to alcohol, that is the important point. See, I given one point. The aldehyde which is attacked by nucleophile first will convert it to acid. Okay. Let us take one formaldehyde and one benzaldehyde. Clear? Right. Formaldehyde and benzaldehyde. Concentrated sodium hydroxide, concentrated NaOH, HCOONA means which is attacked by nucleophile, which is converting into acid. Formaldehyde means formaldehyde is attacked by nucleophile, remember. And another one, benzyl alcohol, right? Which molecule is converting into acid? Formaldehyde is converting into acid. Okay. Benzaldehyde is converting into alcohol. Why? Right. Reason is there here. The aldehyde which is attacked by nucleophile will convert it to acid. Why formaldehyde is attacked by nucleophile first? Let us see. Yesterday we completed mechanism also. See, explanation for this. Explanation or reason. Write formaldehyde and benzaldehyde. In benzaldehyde represent pi bonds. Pi bond. Right. Let us take nucleophile here of OH minus nucleophile. If this formaldehyde will attacked by OH negative, that will convert it to acid. If this benzaldehyde will attacked by OH negative, that will convert it to acid. But which will attacked by the OH minus nucleophile? That is the question. Here we use general organic chemistry, GOC concept. You know this bond is polar bond. Negative positive charges are present, partial positive and partial negative. This is also, but see, small positive charge I am writing, small positive and small negative. Why? This carbonyl carbon is having small positive charge. This pi bond donates its pair of electrons, or benzene ring donates its pair of electrons to this carbonyl carbon. This is having positive charge, right? That positive charge is nullified by pi bond. So positive charge density will decrease due to resonance. So at this carbon, less positive charge is present. So less favorable for the attack. By the nucleophile. This molecule will be less favorable for the reaction. Why? Positive charge density is less. Clear? So here attack, OH minus attack will be very slow. So rate of reaction also very slow. So first, when we take mixture of formaldehyde and benzaldehyde, first which will react with nucleophile fastly? Formaldehyde. Why? In formaldehyde, large positive charge is present. There is no effect like resonance effect or inductive effect to neutralize this positive charge. Clear? The large positive is present, so that will attacked by large positive charge is attacked by nucleophile. So when we take mixture of formaldehyde and benzaldehyde, nucleophile preferentially attacks formaldehyde carbonyl carbon due to presence of a large positive charge. Okay, and here attack is less favorable. That is the reason, right? Very important. So when we take two different aldehydes, writing acid and alcohol is very important step. Clear? Online students got it? Did you get this? Online students. In formaldehyde, large positive charge is present on large positive charge is present on carbonyl carbon. So nucleophile attacks HCHO preferentially. So HCHO converted to acid. In formaldehyde, a large positive charge is present on carbonyl carbon, means this one. So nucleophile attacks HCHO preferentially. So HCHO converted to acid. In benzaldehyde, due to resonance, positive charge is neutralized, means or less positive is present. Okay, not favorable for the attack of nucleophile. That is the reason. So when you have two different aldehydes, check which carbonyl carbon is having large positive charge. Clear? Important example of Cannizzaro reaction. What is the key step? Tell me. Large positive should be present on the carbonyl carbon. Got it, all of you? Online students. Right. Shall I clear this? You can write reason for this also for benzaldehyde. In benzaldehyde, small positive charge is present on the carbonyl carbon due to pi bond resonance. Represent shifting of pi bond this side. Due to resonance or electron transfer, positive charge density will be less. Right? Okay. I'll give you another example based on this concept. Okay. Actually, these your teachers are giving some wrong answers actually. Because this is third year, that's why every year they are giving like that only. That's why I'm saying. Otherwise, I won't say. Okay. Sometimes they can get confusion, but every year they are giving like this only. So be careful with these type of examples. This one and this one, which will convert it to acid. Yes, online students. Concentrated NaOH. First one, why? Why? Why first one converted to acid?
Because epidure and epidure reaction.
What is the key step? When nucleophile will attack? If positive charge is more. NO2 is a which group? Minus M group. So this minus M group increase positive charge on the carbonyl carbon of aldehyde, right? So nucleophile attacks preferentially this carbonyl carbon only. So what is the key step? The aldehyde which is attacked by nucleophile will convert it to acid. Why this is attacked by OH negative nucleophile? Because this carbonyl carbon is having large positive. Why it is having large positive? Due to minus M. Minus M groups withdraw electrons. Clear? So this is having large positive charge. We know minus M plus M groups concept. So this will convert it to acid. COONA. And remaining alcohol. Simple logical. See large positive. Okay. At that site nucleophile will attack and that compound will convert to acid. Okay, correct. You can understand later, I think. No need to give any statement here. Okay, due to minus M group, large positive charge is present. Nucleophile will attack easily. So that will convert to acid. First aldehyde and second aldehyde, which will convert to acid. First group, second group. First aldehyde group, second aldehyde group. Guess. Second aldehyde. Why second aldehyde? Okay. You know one concept. Wait, just a second. Let us take this carbocation. Okay. Wait for some time. OCH3 is a plus M group, right? Plus M, general plus M group. Here also I am taking carbocation. OCH3 is a plus M group. OCH3 is a plus M. Which is stable carbocation? Tell me. Why? Plus M group do not works in meta position. Plus M do not works in meta position. Plus M effect minus M effect do not works in meta position. So here plus M will be cancelled. In the resonance I given this pointer. Plus M minus M effects do not work. In which position? When they are present in the meta position. Here plus M effect is present. Clear? Right. So resonance is very, very important, and I said already in the second year we use resonance concept. First year resonance is important. See here, this NO2 is first one will be attacked. Will be attacked by nucleophile. See here all of first one, yeah. See, first aldehyde is in para position to minus M group. Second aldehyde is not in para position, it is in meta position. Second aldehyde is not in para, it is in meta. So the effect minus M effect of NO2 works on first aldehyde only, because first aldehyde is para to NO2. So NO2 withdraw electrons from the first aldehyde only. Okay. From the second aldehyde it won't withdraw, because both are in meta position. When one group is in meta position, NO2 cannot take electrons. NO2 takes electrons from the group which is para to it. CHO is para to it now. So NO2 withdraw electrons from this only. So here large positive will present, large positive charge. Clear? Large positive charge is present. So OH minus preferentially attacks first aldehyde. So what is the key point? The one which is attacked by OH minus will convert it to acid. Right? Okay, note down. So COONA, NO2 and CH2OH. This is actually internal Cannizzaro reaction. I given under general example only. Actually, we have to discuss this with separate heading, internal Cannizzaro reaction, but we can go without any heading. This is a category of internal Cannizzaro reaction. Right, one more example, one more important example. CHO concentrated NaOH. Here two aldehyde groups are there. This is a category of internal Cannizzaro reaction. One will convert to acid, one CHO converted to acid, another CHO converted to alcohol group. This is also important case. You know, in Cannizzaro, one will convert to acid, another will convert to alcohol. So this is converting to acid, this is converting to alcohol. Internal Cannizzaro reaction. Before that we took separately. Now we are taking into the single molecule. Both the aldehyde groups are in the single molecule. Okay. Are you getting, all of you? Online students? Claisen-Schmidt reaction. Next reaction, Claisen-Schmidt reaction. Any idea? Claisen-Schmidt reaction, online students. What is a Claisen-Schmidt reaction? Claisen-Schmidt reaction. Claisen-Schmidt, no idea. Student, any idea? What is aldol condensation? What is definition of aldol condensation? Aldehydes with at least one. Okay, Cannizzaro reaction is without a alpha hydrogen, right? Now in Claisen-Schmidt reaction, it is a type of crossed aldol condensation. In this, one aldehyde should be benzaldehyde, fixed. When you take one aldehyde as a benzaldehyde, remaining may be anything, aldehyde or ketone with alpha hydrogen. One should be benzaldehyde. Benzaldehyde means without a alpha hydrogen, right? One should be, actually we take two molecules, right? Two acetaldehydes or two acetones, like that we will take. In Claisen-Schmidt reaction, one should be benzaldehyde, fixed. Remaining you can take anything. You can take aldehyde or ketone or anything with alpha hydrogen. But one should be benzaldehyde only. Then only it is called as Claisen-Schmidt reaction. It is condensation reaction. Condensation is mentioned, so you have to discuss this. They mentioned condensation reactions. Important, this is also. Claisen-Schmidt means the condensation between benzaldehyde and aldehyde or ketone or anything with alpha hydrogen. Okay. But one thing should be Benzaldehyde, fixed, that is. Note down the definition. It is condensation between benzaldehyde. Is it having any alpha hydrogen? No. Benzaldehyde and aldehyde are ketone. With at least one alpha hydrogen in the presence of dilute base. Followed by heating. Dilute base, similar to aldol condensation only. In the presence of dilute base, followed by heating. To give alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound. One should be benzaldehyde. That is the condition. Then that crossed aldol is called as Claisen-Schmidt reaction. Important neighbor reaction. It is a type of condensation reaction. What is it? Example with mechanism. Have you completed the definition, online students? Okay. Right. See example. Benzaldehyde. Or I'll give you main reaction. Benzaldehyde and acetaldehyde. Dilute NaOH followed by heating. See the product. What is its name? What is its common name? Tell me. What is its common name? Vanillin. Cinnamaldehyde is the common name. Cinnamaldehyde. Crotonaldehyde, cinnamaldehyde. Shortcut mechanism for this. See the shortcut mechanism. See. You know what is shortcut mechanism? We write oxygen at the end. And from the second, we take alpha hydrogens. Okay, write alpha hydrogens at the terminal. Okay. Alpha hydrogens at the terminal. This is only a shortcut mechanism. Yes or no? Yesterday you wrote shortcut mechanism. I am giving shortcut mechanism only, not main mechanisms. Clear? All of you. Remove water molecule and join the remaining parts. Join remaining units. CH double bond CH CH3. This is cinnamaldehyde. Loss of water gives alpha beta unsaturated. This is functional group alpha beta unsaturated. Okay. You should read for final NEET. Important condensation reactions are the important reactions. Don't skip this reaction. It is a type of aldol, crossed aldol only, but we are calling it as a Claisen-Schmidt, because when we take benzaldehyde in the crossed aldol, that reaction is called as Claisen-Schmidt. Crossed aldol. It is a crossed aldol or not? Different aldehydes you are taking. But if you take one of the aldehyde as benzaldehyde, you should call it as a Claisen-Schmidt reaction. Okay? Right. Completed online students. Have you finished? Right. Next, right. Last one, benzoin condensation. Benzoin condensation. Benzoin condensation. Aldehydes without alpha hydrogen. Aldehydes without alpha hydrogen. Say benzaldehyde. Benzaldehyde is not having alpha. Aldehydes without alpha hydrogen. React with cyanide ions. React with the cyanide, Cl minus ions to give alpha hydroxy ketones. To give alpha hydroxy ketones. Alpha hydroxy ketones. Alpha hydroxy ketones. Just you remember the product in alpha position, hydroxy group will be present. Okay. See this. NaCN or KCN. So cyanide ions I mentioned, no? So what is the source of cyanide ions? NaCN or KCN? NaCN or KCN. What is the product? You tell me. What is the product? What is the product? Alpha hydroxy ketone. So very easy to identify benzoin condensation reaction. Very easy to identify the reaction. This is alpha position. In alpha position, hydroxy group is present or not? So that is the hint. That is the hint. Okay? That is the hint. Benzoin condensation. In alpha position, hydroxy group is present. Mechanism is not important. Okay, for NEET level. Just you remember, alpha hydroxy ketone is the product in benzoin condensation. Haloform test. Haloform test or haloform reaction. Haloform reaction. Haloform reaction. This is over in the alkyl halides chapter, first chapter. In the chloroform preparations. Chloroform preparations. Any idea? Any idea? Beta methyl group. Beta methyl group. Ketones with at least one alpha methyl. Ketones with at least one alpha methyl undergo haloform test. That is important condition. Beta methyl condition is for alcohols, not for ketones. Okay. Very important reaction. This will come. Okay, we can expect this for your weekend exam. First of all, let us understand the reaction. This is ketone. Ketone. This is functional group. Functional group. Alcohols is beta methyl. You should say that. But for ketones, now we are discussing which chapter, aldehydes and ketones, right? Alcohols are given. But ketones, regarding ketones, the property, chemical property of ketones we are discussing here. This is not alcohol chapter now. In alcohols, we should say that beta methyl alcohol. This is alpha methyl ketone. Both will undergo, but Particularly, we are discussing chemical properties of ketones. Aldehydes and ketones here. Alpha methyl group. Regarding ketones, I thought you thought about alcohols. Correct only, no? That's why you give an answer like that. Regarding ketones, alpha methyl group, functional group C double bond O, C double bond O, alpha position, having methyl group, alpha position having methyl group. Reagent of haloform reaction, NaOH, sodium hydroxide plus X2, where X is equal to chlorine, bromine and iodine. Very, very important, another type of representation, NaOX, NaOCl, NaOBr, NaOI. If you observe NaOI, you have to consider that reaction as haloform reaction. NaOCl, haloform, NaOBr, haloform, or NaOH plus Cl2, haloform, along with the alpha methyl ketone. Clear? Right. See how to write the product. Wait. First write R as it is. Shortcut mechanisms. Write R as it is. After writing R, immediately attach COOH group. Clear? In haloform test or haloform reaction, carboxylic acids are one of the byproducts. Right? One of the product. First write this R is there now, whatever it may be there, structure, it is open chain or cyclic or anything, take R as it is and immediately attach COOH to it. Clear? Means this part is going to convert to carboxylic acid or COOH. Next another part haloform CHX3, remaining part is CHX3, haloform. This is haloform, chloroform, bromoform, iodoform. Right. See, writing the product is important. Okay. What is the trick? First to write R as it is. To the R attach COOH and convert CH3 to CHX3. Clear? Okay. Let us see one example. Online students, are you following, all of you? Are you following? Let us see this example. CH3, CH2, C double bond O, CH3. First of all, tell me, will it undergo haloform test? Why? Alpha methyl. Right side methyl group. Right side. Left side methyl is not there. Ethyl is there. This is ethyl. It won't means it is not considered as a methyl. So this side methyl is there. Yes, it undergo. Can I take this as Cl2 in place of X? Or tell me. Because everyone prepare how to write the product shortcut from everything. They neglect this part. NaOCl means NaOH plus Cl2. When these two combine, this is formed. Okay. This representation, both are same. Right. Writing the product. How to write the product? Tell me, what is the trick? What is R here? This is R. Write R as it is. CH3, CH2. R. After writing R, COOH or C double bond O, COOH. Next, this one. Yes, CH. Because we took chlorine here. Right? So this part will convert to acid or COOH. This part will convert to haloform CHX3. That is the trick. Original mechanisms won't work. Already we completed original mechanism. Okay. For aldol condensation, for Kenichiro reaction, for this original is not needed. Shortcut is enough. Next. Can you write the product and say the carboxylic acid for this? First of all, tell me, will it undergo haloform test? Will it undergo haloform test? Yes. This is C double bond O. Terminal carbon represents CH3. CH3. Here CH3. How to imagine? CH3. I'll give you another form if you don't know. See, this can be represented like this also. C double bond O CH3. Both are same. This. Both are same. Okay? Write the product. What is R here? What is R here? Yes, cyclohexane ring. So cyclohexane ring. R as it is, then immediately attach COOH plus CH3 converted to CHCl3, CHBr3. Yeah. Bromoform. I'll give you one important question, model question. Note down that which of the following undergo haloform reaction? This is based on nomenclature, complete nomenclature. Okay. Which of the following give haloform test? So the following give haloform test. Acetone. I said to learn the structures. Acetophenone. Expected question. This is acetophenone. 2-pentanone. 2-pentanone. 3-pentanone. Benzophenone, right, bit down. Benzophenone. I given nomenclature already at the beginning. I given nomenclature already. ABC. Other students, please respond. You also, please give a response. Give the response, all of you. See, acetone structure. CH3, C double bond O, CH3. It is having alpha methyls, 2 alpha methyls. Yes. 2-pentanone, second position C double bond O, 2-pentanone. Yes. 1, 2, 3, 4, 5, 2-pentanone. This is alpha position. Yes, 2-pentanone. Acetophenone. What is acetophenone structure? One side CH3, other side benzene ring. Important names, all these are very, very important. 3-pentanone. 3-pentanone what? Yes. CH3, CH2, C double bond O, CH2, CH3. 2-pentanone. Give T into mark. Benzophenone. In benzophenone, CH3 is not present. Yes, both are benzene rings. Correct. Both are benzene rings. It won't give. And this one. What about this one? Yes. C1's alpha position. This is functional group alpha. This is next is beta. Okay. Alpha, beta, like that. At alpha, CH is there, not a CH3. This is next beta in beta, so it won't be. Exactly at alpha, it is not possible with cyclic. Not possible with cyclic. Alpha, beta. Alpha next position, beta. In the next methyl is there, not at alpha position. Not at alpha position. Okay. Right. This is about
I don't know.
chemical properties.